Ayush will explain the architecture of Factbook.
Hi everyone, this is Ayush. I will be walking you through the architecture of the Factbook. We will start with the backend design. To build the Factbook, we needed to scrape the world data that is available on the CIA World Factbook and Wikipedia webpage. We chose Python-based Beautiful Soup library for our scraping service because it is the most widely supported scraping library in the industry. Once the entire data is scraped from the two sources, it is merged together and stored to a persistent file system for faster recovery. In the case where the database goes down, the latest data from the file system will be ingested to the newer instance of the database. Once all the data is stored in the file system, our Python-based ingester will ingest the data from the file system to our Elasticsearch database. We chose Elasticsearch as our database because it provides inbuilt faceted search functionality that allows our system to filter the data in real time. Next, we're using Node.js to allow performant query transactions between the frontend and the Elasticsearch. The Node API will act as a thin middleware that will authorize each request going to the Elasticsearch that's coming from the frontend. Moving on to the frontend, we will start with React.js. We chose React.js for the frontend because it is one of the most widely used frontend frameworks with many readily available components. React is fast, scalable, and has low learning curve. We embedded Leaflet.js to our React application for showing the maps. Leaflet.js is an open source interactive maps library used to visualize data in real time and is widely used with React.js. Further, we are using Nginx as a reverse proxy server for handling large traffic. Nginx will also protect our frontend against any malicious requests. To visualize the data on the maps, one has to use GeoJSONs. While the GeoJSONs for each countries are readily available on the internet, we needed to store them to some place where our application could query them instantly and from any part of the world. So we chose JSDeliver as our GeoJSON CDN. JSDeliver is an open source CDN for hosting JavaScript files and making them available to users from their nearby CDN servers. For storing the images to be shown at the front end, we chose Cloudinary. Cloudinary allows us to load different sizes of same images for different screen sizes. Because our application is responsive, one can also open our application on a mobile device. While students can open Factbook from their laptop to complete their projects, commuters can gain access to these readily available facts on the go on their mobile phones. Next, combining the front end and the back end, this is the entire architecture. We have deployed our front end, back end, the Elasticsearch database, and the scraping service to the DigitalOcean infrastructure because it provides cheap compute along with the support of Kubernetes, which could be used in future to scale up or down the application depending upon the load. Further, I would like to show with what our team has achieved so far. As you can see, these are two available views for the desktop and the mobile. In the desktop view on the left, the filters that you see, the, these are called facets that were mentioned by Mitali earlier. Based on the filters chosen by the user, the map and the list of the countries gets updated in real time. Next, I will hand over to Ananya to show the demo of our entire workflow.
Hi, my name is Ananya and I'm here to demo on what we have done till now.